All right, hello everyone. Today we're taking on chapter 5.6. We're looking at the standard normal distribution. And one thing that you're going to need for this lecture is the z-score chart that I have posted on today's date. So again, this is what you're going to need. You're going to need a standard score or z-score chart. I've picked one that is pretty user-friendly, pretty basic, and easy to use. That is the goal. All right, so here. So far, we've learned how to calculate areas under a normal curve when the values corresponded to integer values. So -3, -2, -1, 0, 1, 2, or 3 standard deviations from the mean. So now we're going to learn how to calculate the areas that correspond to other values. So here first, I'm just showing you that bell-shaped curve, reminding you of where we've been. Right here, we're 0 standard deviations from the mean because this is where the mean is. Here, we are 1 standard deviation above, 2 above, 3 above. 1 below, 2 below, and 3 below. Now, we've calculated z-scores in the past. So here, first, I just want to remind you that what we like about a z-score is it strips away the units, right? Eliminates units from our data. We are standardizing. Let's start with that. So eliminates units from our data. We think of that as standardizing. Okay, and what's nice about that is it enables us to compare data sets that may have different units or different magnitudes. Okay, and then each of these values, the actual z-score, it's really specifying for us how many standard deviations a piece of data falls from the mean. So right here, we would be 1 standard deviation above the mean because it's positive. And over here, say I look at this one, this would be 2 standard deviations below the mean because it's negative. So again, it specifies how many standard deviations a piece of data falls from the mean. So again, if we see a positive value, right, then it is above the mean, and if it's negative, it's below the mean. A z-score of 0 will mean it is exactly the mean, right? Because we're 0 standard deviations above or below, we are the mean. Okay, so if we think in terms of area increases as we move from left to right, right? Because we're thinking of the area that falls below. So if I'm over here, right, I have a really tiny bit of area that falls to the left. And as I move up, that area that falls below, the area to the left, right, it's increasing. So the area is close to 0 for a z-score that's close to -3.5. So over here, if I'm thinking of the area of what falls below, right, it's super close to 0. Okay, and then as I move to the right, the area increases as the z-scores increase as well. If I stop at a z-score of 0, right where the mean is, well, that's a 50-50 split. Half of my data is below and half of my data is above. Okay, and then once I get up to this extreme way over here, so say I'm at 3.5, my area is really close to 1 when my z-score is at about 3.5. That accounts for most of my data. Most of my data would fall at 3.5 or less. If I go to my z-score chart for just a moment, you can see the same thing. So the way that it's organized is it's showing us the proportion that falls below, the area that falls below. So I can see that as my z-scores are increasing, that proportion below those areas it's increasing. So here, at a z-score that was negative 3.5, that proportion below was about 0.0002, and I can see that it's increasing, up until here where it gets to about 3.5, right? And it's getting really, really close to 1. All right, let me go back. So first, before we even do anything with the z-scores, I wanted to review some absolute value equations and inequalities. So here is a nice flashback to Algebra 1 and Algebra 2. All right, so solve each absolute value equation or inequality and graph. So here I'm saying that the absolute value of x is equal to 4. Well, absolute value, we can conceptualize it as a distance from 0. So absolute value of x is really saying, well, we're saying that the distance from 0 is equal to 4. So from 0, I can move to the right 4 units or to the left 4 units, which would give me two specific answers here and here, where x could be negative 4. And my other option is that x is positive 4. Okay, so if I go back here, absolute value of negative 4, right, those bars forcing it positive will produce a positive 4. And a positive number, forced positive, still positive, will still be 4. Okay, next up here, absolute value of x is equal to negative 4. So we're saying the distance from 0 is less than 4. Well, that's not possible. I can also just think, no matter what I plug in for x, whether it's negative 10, 0, positive 10, it's never going to produce a negative number over here. It would be impossible. It can produce 0 or something positive, but it can't go into negative territory. So here I'm just going to say no solution. And just remind you that a positive number cannot equal a negative number. All right, next up, absolute value of x is less than 4. So we're saying the distance from 0 is less than 4. So here I'm at 0, and I'm going to move away 4 units and 4 units. So here I'm 4 units away from 0, both sides. And I'm saying that the distance from 0, right, is less than 4. So less than 4 would be anything in here, anything in here. Over here would be more than 4. So my solution region is this in between here to here. So how could I write that as a solution? Well, in inequality notation, I could say, well, from negative 4 to 4. So this is saying x is less, or x is greater than negative 4, but at the same time less than positive 4. So this, again, this is using inequality notation. But I could also use interval notation and say from negative 4 to positive 4 with that soft bracket or parenthesis. This is my interval notation. They both work. Does not matter to me. Okay, next up, absolute value of x is greater than 4. So here, again, I'm at 0. I can move 4 units away here to here. And I'm saying that the distance from 0 is more than 4 units away. So that's telling me that it's these outer portions out in here or out in here. So I could, in inequality notation, I can say x is less than negative 4 or x is greater than 4. I could also say from negative infinity to negative 4, parentheses, union with 4 to infinity. I could write it in my interval notation like that too. They both work. Again, does not matter to me. All right, next up, absolute value of x is less than negative 4. So the distance from 0 is less than negative 4. Well, how is that possible? Right? I can't have a distance that's less than something negative. There'd be no solution. Another way that I can think about it is, no matter what I plug in here, the bars are going to force it positive. So there's no way that a positive number can be less than a negative number. So again, we got no solution. I'm going to have you write one more time, a positive number cannot be less than a negative number. All right, last up, absolute value of x is greater than -4. So we're saying that the distance from 0 has to be more than something negative. Well, that's always going to be true. That's going to encompass everything. Anything that I plug in for x will make that true, right? I could plug in something negative, something 0, something positive. No matter what, those bars will force it to be positive, and it will be more than something negative. So my answer could be all real numbers. I could write it like that, or I could use interval notation, negative to positive infinity. That would be fine also. And then here, just a reminder, a positive number will always be more than a negative number. All right, so again, just going back to absolute value, doing a nice little flashback to Algebra 1, Algebra 2. All right, flip your sheet or pull out that second sheet. And here we go. So you definitely need your z-score chart out as we work through this activity. Okay, so here now we're picturing the standard normal curve. And I'm saying find the area under the standard normal curve that's to the left of a z-score that's -1.9. So here I usually anchor myself right here. There's my mean, right? That's where my z-score is 0. So I'm thinking, where would -1.9 fall about? Well, not right here. So here's where z equals -1.9. And I'm looking at the area to the left, right over there. So that's exactly what my z-score chart is going to use. It's going to use the area that's to the left of that z-score. So when I look at -1.9, here's -1.9, and it's telling me the proportion below the area to the left. So the area to the left will be 0.0287. Okay, next up for B, find the area under the normal curve that's to the right of a z-score of 1.6. So again, here's my mean, that's z-score of 0. So here would be 1 standard deviation, here would be 2. So here is about 1.6. And I'm asked to find this area that's to the right. So my z-score chart is always telling me what is to the left. So if I look up a z-score of 1.6, right here, it's telling me the proportion below. So it's telling me this area right in here. But I want the opposite. So I need to do 1 minus the region that was to the left. So that was the 0.9452. Okay, so I need to get 1, take away 0.9452, and I get 0.0548. Okay, next up, find the area under the standard normal curve between a z-score of -2.5 and a z-score of 1.3. So again, here's my mean, a z-score of 0. Here would be about where that -2.5 would fall. And here would be about where that +1.3 would fall. And I'm looking for the region in between. So this is my solution region. So again, when I'm using my chart, when I look up a z-score of 1.3 first, so 1.3, that's telling me the area that is fully to the left, like that. And then when I look up a z-score of -2.5 right there, it's telling me the area that is to the left. So what I need to do is I need to figure out what is the area to the left of the 1.3, and then I need to subtract the area that's to the left of the -2.5. So for the 1.3, the z-score was 0.9032. Okay, so the z-score of 1.3 gave me a proportion below of 0.9032, and then I need to take away the 0.0062. And it's going to leave me with 0.897. Okay, so again, let me just redraw that for you. So I start with my normal curve, and I start with that 1.3. So that gives me all of this area to the left. So that gives me the 0.9032. But then right here, when I look up the z-score of negative 2.5, it will give me the area to the left right here. So that's all I'm doing, is I'm finding this whole area to the left, and then I'm subtracting this area to the left to get what's in between. And that's what got me to that 0.897. All right, example 3. What percent of a standard normal model is found in each region? So here I'm saying a z-score is less than negative 1.4. So here is my mean, the z-score of 0. So I'm just going to put right about here is where z is negative 1.4. And I'm looking at the less than, I'm looking at the below. So when I go to my chart, I should see 0.0808 as the proportion below the area below. But the question is saying, well, what percent falls in this region? So I just have to make it a percent. So 8.08%. Okay, next we're saying a z-score that's greater than 2.3. So here's my mean, that's a z-score of 0. So 2.3 would be about right here. And I'm looking at the more than, I'm looking at the above. So I know that if I look up 2.3, it's going to give me the proportion that's below. So I need to do 1 minus that proportion below to get to that proportion above. So let me look at my chart. That 2.3 was 0.9893. So 1 minus 0.9893 is 0.0107, or 1.07%. Okay, next up here, I'm looking at the percent that falls in between these two markers. So let me first write the mean. There's my z-score of 0. Slide this up just a smidge to there. Okay, so negative 1.7 would be about right here. 2.4 would be about right here. And I'm looking at the in-between. So when I look up each z-score, again, it's going to give me that proportion below. So when I think about what is it that I have to do, I'm going to have to look up the z-score of 2.4, find the proportion below. So if I start with that, the z-score of 2.4, the proportion below is 0.9918. Okay, and then I look up a z-score of negative 1.7, and I find its proportion below. So for the negative 1.7, that's 0.0446. So what I need to do is I need to look at this area right here, the 0.9918, and then subtract this area right here, the 0.0446. So 0.9918, take away 0.0446, it's going to get me 0.9472, or 94.72%. Okay, next up here, absolute values. We're seeing absolute values show up. That's why we practiced it on the other side. So absolute value of z is greater than 1.1. So what that's saying is the distance from the mean, where the z-score is 0, has to be more than 1.1. So here's my mean, a z-score of 0. Here I'm at about the 1.1s. Here's the negative 1.1. Here is the positive 1.1. So the distance from the mean is greater than 1.1 away from the mean. So it's having me calculate these two tails. And what's so nice is that the area right here will match the area right here. These two values have the same magnitude, the same distance from the mean. So the proportion that's below the curve here and here, it's going to match. So if I look up the first one, if I look up a z-score of negative 1.1, the proportion below is 0.1357. Okay, for this one, I could do it the old way, right? I could do 1 minus the proportion below, but I'm going to tell you it's going to get me the same thing. So the proportion that is to the right of the 1.1 to the right will end up being the same, 0.1357. So I really just have to add those two. So I'm adding up the 0.1357 to itself, and that gets me 0.2714, or 27.14%. Okay, last one right here, absolute value of z is less than 1.6. So the distance from 0, from the mean, where the z-score is 0, is less than 1.6. So here's my mean, the z-score of 0. Here I'm at about 1.6 above, and here the below. So again, let me just read that back. Absolute value of z is less than 1.6. So the distance from the mean, where the z-score of 0, is less than 1.6. So less than is going to be the in-between region from here to here. So here I need to look up a z-score of 1.6. The area to the left is 0.9452. And for a z-score of negative 1.6, the area to the left right here is 0.0548. And now I take the difference between the two. 0.9452 take away 0.0548, and that gets me 0.8904, or 89.04%. All right, that's what I got for today. I hope you guys are doing well. Feel free to review anything or send me questions. I'm happy to answer them. I hope you guys have a great day.